Today I'm going to show you a prototype tool that we built that makes it dramatically easier for all kinds of people to take data and models and make predictions about things that really matter, like food or fire. Here's a fire model showing predictions for fire frequency across the United States for the next 20 years. In general, we know how to make those kinds of predictions. We need to take data and models and combine them together with Bayesian analysis to make predictions. But the technical challenges involved in that pipeline are so severe that it's difficult even for the experts to do that stuff, and most people can't even get started with it at all. So I'm just going to open our prototype. Everything runs in the browser. And what I'm going to do is use this application to build a model that predicts the yield of wheat as a function of the climate. So I'm going to import a file, and we see that it has latitude, longitude, and then the yield of wheat. We're going to make a chart so we can see how the yield of wheat varies across the world. And now I'm going to supplement that file with the climate information that we need. So I'm going to use our fetch climate service, which is baked into the application. And just that quickly, I could go and get the temperature. I didn't have to supply it myself. It was supplied by the tool. I can go and get precipitation as well. And immediately then we can have this table with the yield of wheat, the temperature, and the precip. We can go and make a chart, which shows how the yield of wheat depends on the temperature and precip. So the next step is to build a model of the relationship between the yield of wheat and the temperature and precip and fit that model. Now the model predicts the yield of wheat, and I'm going to add a dependency of the yield of wheat on air temperature. I'm going to also add a dependency on precipitation. And I've done everything I need now to go and fit that model to the data, which is what's happening here with a fully state-of-the-art Bayesian analysis, MCMC, parameter estimation as we call it. This has now estimated the parameters in the model, like for instance the optimum air temperature of wheat, and it's telling us that the optimum air temperature is about 12 degrees. And here's my predictions, which I'm going to, again, view on the map. It's a very flexible graphical system. We can look at all sorts of different aspects of the data here. And this particular view shows the model predictions then across the world, including the uncertainty. So we could put all of those various charts in there, and we can see whether our model looks like the real world, and it does seem to have done quite well. Now, if I want to share this whole analysis with someone else, I just hit a single click up here, and I've just saved a file that I could share with you. You could open it and retrace everything I've done, modify anything, and extend off it to build ever more sophisticated models. So with just a few clicks of the mouse, we've been able to take that model and the accompanying parameters and make it available via the cloud in our Fetch Climate 2 service. You can see that here. We can go forward then and look at some projected possible wheat yields under a climate change scenario. And those same predictions are actually available on a phone. What I hope I've been able to show you is that we can make it dramatically easier for people to go from big data to models to predictions about things that really matter. And that then gives us the ability, hopefully, to make much better decisions about how we look after the planet on which we all ultimately depend.